to the Voices for Victory podcast. I'm your host, Heather Burns. Joining us today is Susanna Greer. Dr. Susanna Greer, PhD, is the Chief Scientific Officer of the V Foundation. In this role, Dr. Greer is a visionary ambassador of the V Foundation who works with our Scientific Advisory Committee to steer funding to the most promising research opportunities. An accomplished strategist, she develops and articulates priorities to enhance the V Foundation's research portfolio, gifts, grants, and sponsorships. These are designed to advance the V Foundation's distinctive brand of cutting-edge and disruptive research. Susanna has spearheaded the A Grant of Her Own initiative for the V Foundation and will be leading our V Summit this month. Susanna, thank you for taking the time to join us today.
Thank you so much, Heather. I'm delighted to be here.
We are too. So were you always passionate about cancer research? What in your background made you choose this field?
I have always been passionate about understanding things that are hard and difficult. Always enjoyed math and science. And when you think about the most challenging diseases that affect humans, cancer is top of the list. So I would say as I became more and more educated about science and biomedical research, I wanted to do the tough things. And cancer, honestly, is, I would say, the toughest.
Yeah. So when you were like, how long have you wanted to do this? Like since you're a little kid, or like, did you choose this in college or high school? Like, tell us a little bit more about, how it came to be.
Sure. It's a great way to make me think about the old days. So I grew up in the South, in the deep South. I'm from Georgia. And so two things I think combined. One is that when I was a kid and still now, when you were a girl and really good at math and science, everybody told me to go to medical school. You'd be a great doctor. I mean, no one really thought about or ever suggested research as a career. I didn't even really know it existed. I had a wonderful AP chemistry teacher in high school. Her name is Susan Smith. And she saw that I was talented in chemistry and suggested that when I went to college, I should think about working in a lab and trying to get more research experience. And so I did that. So that's the first, and I've always been a bit of a rebel. So when people would tell me, including my parents, you should do this or that, I pretty much went the opposite direction. So as I, in college, began to learn more about research and opportunities in labs, I was a TA in a physical chemistry lab, and I absolutely loved it. And even though everybody was still saying, you should be a doctor, you should go to med school, it really did not feel right to me. You can ask my husband. I'm very impatient, especially when he's sick. So I didn't know that medicine would be the right area for me. I just really love the challenge of being a researcher and being in the lab. So take that path with the fact that many of my family members have been diagnosed with cancer. And I attribute a lot of it to they are out in the sun a lot. They are farmers. They are also exposed to chemicals that we put on crops and pesticides that we still use in many cases to prevent intrusion of insects onto crops. And so my family over the past 50 years has had higher than average cancer rates that are due to environmental insults. So when I combine the things that I love, research, thinking about hard things, cancer, and my family's own experience with cancer, it seemed like the perfect career. And then I went to graduate school and got a PhD in microbiology and immunology. And my PhD coincided with a time in the late 1990s and early 2000s that we were just starting to understand the true role that the immune system plays in all of us all the time in preventing cancers. And those of us who are lucky enough not to have a cancer diagnosis. And then fast forward over the next 2 decades, our understanding that we can manipulate the immune response in individuals who have a cancer diagnosis. And so as I furthered my own education, had this desire to think about hard things, big challenges. I mean, we are still discovering new immune cells all the time. And so that dovetailed with my family's impact and engagement with cancer, and then my own fields beginning to engage with cancer in an enormous way. So immunotherapy became my first love and has remained that place, thinking about the immune response to cancer and how we can manipulate that for decades now.
Yeah, so I can't imagine the difference between immunology back in the 90s and where we are now. Can you speak to that and how immunology is affecting cancer treatment?
Absolutely. In the 90s, we understood certainly that immune cells recognize cancer cells, and one of the holy grails became, and still is, thinking about what is it about cancer cells that the immune system can recognize that's different from our own cells. The biggest challenge in thinking about the immune system in cancer has always been this central dogma that cancer cells come from normal cells, right? So the immune system has a much easier job when we are infected with a virus, for instance, because it's easier to tell that a cell has secreted viral proteins, or a cell is infected because it changes, it's stressed, or things about the cell change because of the way it looks on the cell surface. It makes it really different from a normal cell when it's infected. And that's different for cancer cells because cancer cells start off as being normal cells. They develop one or two characteristics. One characteristic meaning they develop the ability to divide indefinitely. And the worst cancer cells also develop the ability to invade other tissues or metastasize. And so along the way, these cells that start off as normal become abnormal and cancerous, but they still have all these same characteristics of being just normal cells. So it's hard for the immune system to determine what is normal and then what is cancer. And are there things that we could determine that maybe all cancers have in common, or all breast cancers, or all prostate, or all colorectal cancers that we can then target and help the immune system out with a drug. So I would say in the difference now is that was our early understanding decades ago, is that we knew cancer cells come from normal cells, they change, and we can target those changes. And so thus began decades of really looking for what were those specific changes. And now I think we're realizing just how little we understood. Now we understand that not only does the cancer cell itself change and develop those abilities to divide indefinitely and to invade, but also the environment changes. Not every component of the immune system is good for us. There are components of the immune system that can be manipulated by the cancer cell to help the cancer to grow and to kind of shut off the parts of the immune system that are there to eliminate the cancer. We call that the space around the tumor microenvironment. And our understanding of that has robustly grown in the past decade to where we now understand that the job that we thought we had to overcome, which was just alerting the immune system to the cancer cell, is really only maybe a third of the battle. You have to alert the immune system this is a cancer cell. Then you have to suppress the parts of the immune system that are pro-cancer. And you also have to deliver the appropriate immune cells to the right cancer cells at the right time without causing undue damage to the host, which is us. So if I had to just say what are the things we've learned, it's just more a holistic understanding that it's much more complicated than we thought to manipulate the immune response to cancer. But also we've had some tremendous successes, and we will continue and are continuing to have more and more and more as we understand just how complicated these challenges are.
Yeah, and it's so exciting. And I never, like before I came to the V Foundation, I didn't realize the amount of progress has been made in that field. And oftentimes I've been hearing that it's the future of cancer treatment. So really exciting stuff for sure.
Absolutely.
So how did you become a part of the V Foundation? What led you down the path to the V Foundation?
Maybe I'm just the luckiest person in the world. I'm not sure. I've always been interested in helping other scientists. After my postdoctoral fellowship, I ran a research lab at Georgia State University, and that was a cancer immunotherapy lab. Loved being what we call a PI, so a primary investigator. Had undergrads and graduate students and postdocs in my lab. I taught immunology at the graduate level and really loved it, and went through a couple of cycles of grad students who would come to the lab. Typically graduate school takes about 4 to 6 years in biomedical research. And so I had done that maybe twice. I was tenured. And along the way, I was funded by multiple nonprofits. And when nonprofits, including our own, realized you're a good speaker, I had been asked to speak on behalf of nonprofits. And I loved it. I had a knack for it. I was good at it. I had other faculty members who would ask me to help them with their slides. My university asked me to speak on behalf of the university. And so it became pretty obvious to me that I had a skill for talking about science, my own science, other people's science, in a way that other people who did not have an expert background in science could understand and be excited about. And so when I was a professor, I launched a consulting firm, a science communication consulting firm that did just that. We helped other scientists to develop pitches for angel investors who were excited about their work and wanted to learn a little more. And that led me to realize that perhaps I could make just as big an impact in cancer research by helping other scientists than in my own research lab. So that was the beginning of a path that led me to the V Foundation.
Awesome. So you mentioned a little bit about working with other nonprofits. I guess they funded your research. So now you're on the other side of that. So can you tell us about the grant process and how a grantee is chosen to be funded by the V Foundation?
Absolutely. I am biased, of course, because I am an employee of the V Foundation, and I wouldn't work here if I didn't think that we did the most outstanding job picking the best researchers and the best research to move the bar in cancer. But I can also tell you I have a vast amount of experience in this space. So I think I come from a place of privilege and understanding scientific review and the process that needs to be in place to make sure an organization is doing that. So you asked me how I came to the V Foundation. The reason I was so excited to join the V is that we are the best at picking the best science that will move the bar in cancer. The way that we do that is we do not accept unsolicited grant applications at the V Foundation, meaning no matter what you're doing anywhere in the United States, you may be doing really wonderful work in cancer, but you can't just send us your ideas. You can't just write a grant and send it to the V. Our process is such that we have requests for applications multiple times a year, and those requests only go to designated cancer centers. A designated cancer center is a title given to a cancer center that has overcome an incredibly rigorous review by the National Institutes of Health and has shown to be a place of not only prominence in research, but research that spans developmental research, translational, and clinical research. These are really, really difficult titles to achieve. Right now, there are 72 designated cancer centers in the United States. So several times a year, the V Foundation solicits nominees for our grant process from designated cancer centers. So each designated cancer center can nominate one individual. The nomination process is different at each cancer center, but it is rigorous. As you might imagine, researchers working at these cancer centers are truly the best of the best. So each cancer center can nominate one individual. Those individuals then go through our administrative process to make sure they're eligible for each of our different requests for applications. And as long as they are eligible, they then compete against each other. So for each of our grant applications, we have two levels of selection. One is the nomination at the level of the cancer center, and the second is the competition against each other. Those grant applications are reviewed by our scientific advisory committee, which is composed of the most prominent cancer researchers in the United States. These are cancer center directors. They are leaders in their field, and they rank the grant applications from best to worst. And remember, worst came from the very best applicant from a cancer center, a designated cancer center. And we fund applications that are ranked as outstanding by that scientific advisory committee. So when I am in front of a donor, the great privilege that I have is to say that this research that has been recommended for funding by our scientific advisory committee, this is the best research being done by the best researchers in the United States. Full stop.
Wow. So, yeah, and I hear a lot about young investigators as well, and that is kind of what we look for in funding. So, does the best of the best necessarily also mean young investigator, or how does that work?
Yeah, that's a great question, Heather. One of the concerns that I have in the scientific workforce, just in general, is just how hard it is to survive. We're an organization that thinks a lot about sports because our founder, Jim Valvano, was a beloved ESPN commentator. He was a basketball coach. And I think there are also a lot of parallels with sport and science. So for an investigator, I can think about an investigator being like a basketball player, right? Who, most basketball players just don't show up and play for the NBA, right? You've played since you were probably, a little bitty kid, and maybe you played in elementary school, and then you were the best and you got picked to be on your junior high school team, and you were the best and you got picked to be on your high school team. And then, you practice and practice and practice all the time. And lo and behold, you made it to your college team. And then what? The 0.0001% maybe make it to the NBA. Similarly, for scientists, the career path is just as rigorous. So we go through K-12, right, and have an aptitude for science, and then go to undergraduate, where we would probably major in some type of biomedical area. And then following undergrad, so now we're 16 years of education in my field, we would either pursue a PhD in biomedical research. So that would be something like genetics, immunology like me, cell biology, physics, computational biology, or we would go to medical school. And so let me add all these years up. So we've gone to undergrad for 12 years. We've then gone to grad school. We've added another 4. And then we do a postdoctoral fellowship, which is a way to further refine your skill set and really zero in on the area that you want to focus in. So in my case, I was in graduate school, I got a PhD in immunology. And as a postdoc, I narrowed that in on kind of cancer immunotherapy and thinking about the immune response to cancer. You go to medical school, you then do a residency. So following all of that education, you then have to start over again. So you've risen to the top all of those times, right? From undergrad, graduate school, and then further training as a fellow. You have to start over because you design a research career that is different from that of your postdoctoral mentor. So you take all of that education, all of your ideas, all of your excitement, you apply for a job as an assistant professor. And if you're an individual who has really risen to the top, knocked it out of the park all these times, you would get a job at one of these designated cancer centers, right? The best of the best of the best. And you have a very limited time now to perform hypothesis-driven research, generate enough preliminary data to obtain your own funding to fund your lab. And that is such a precarious perch to be in. So one of the concerns I have about the research pipeline is I want the best of the best researchers to be in cancer research. I want them to be able to take their exciting, innovative ideas and think about new technologies, new devices, new drugs for cancer. But that is a tough career path, right? I mean, I added up an enormous amount of education. And then at the end of all that education, you have the risk that you don't make it, right? You don't get that grant. The average age of the first large research grant from the National Institutes of Health is 45 years old.
Wow.
So I really struggle with that. So at the V Foundation, one of our legacy grants is called the V Scholar. And the eligibility restriction is that you must be an assistant professor. So you've got to be in those first years of having your own independent lab. And you can't have a large grant from the federal government or a large grant from another nonprofit. So it's really hitting that sweet spot of investing in high impact and potentially high risk science. But it's those high risk grants that can pay off just in spades. So that's a place where the V Foundation really shines. We can be nimble and we can make those investments to help launch careers. So it's probably one of the programs I'm the most proud of at the V Foundation.
Yeah, that's awesome. And we're also really excited about our V Summit in April. And we're going to have, I guess, all of those V scholars and all of our researchers and grantees will be there, correct?
Well, yes. So the V Summit, many of them, exactly. So the V Summit is designed to be a career development opportunity for our current group of grantees that are in that early career space. It's hard. It's hard to feel alone as an assistant professor. I remember when I was starting my own lab, I also had a baby. One of the things I think is so interesting about science is that you make it to all of these different levels and then quickly don't use the skill set that got you there. So probably the most difficult is that transition from being a postdoctoral fellow or a resident to leading your own lab, because what gets you there is the ability to perform amazing science, right? To do hypothesis-driven research, to write papers. Maybe you've gotten some grant funding. And then very quickly, when you become an assistant professor, you become a manager. You're managing projects, you're managing people, you're managing budgets, you're managing your time, you're pulled in a billion different directions, and it can be very lonely, because you are looking at other faculty who seem to have it all together, who are ahead of you, who have already been tenured. And I don't want that to be the case for our grantees. I want them to feel a sense of support, certainly from us, also a sense of camaraderie with each other. And what better way to help them to communicate their ideas with each other, to collaborate, than to bring them together once a year. So literally, we are bringing the best of the best young investigators in the country together once a year to say, hey, you all have common ground in that you have been selected for funding by the V Foundation. You have these amazing projects. We are invested in you, and we also want to invest in your professional development. So we equip them with tools to communicate their science, to have long-term relationships with each other. And it's just an absolutely incredible experience.
Yeah, I'm really excited about going. This will be my first one too. And I come from the entrepreneurial world. It's very similar. I feel like being an entrepreneur and being, running your own lab and the loneliness that can happen and not feeling supportive. So what an enormous resource for them to have that camaraderie with other grantees.
Yeah, absolutely. Just to be able to ask the questions, what did you do when X, Y, and Z happened? How did you handle this problem? I mean, you feel so alone until you begin to realize that other people have the same challenges, other researchers, and what better way to learn than from each other? One of the things that I love that we do is we bring in previous V scholars to speak on a panel to our current grantees. And these are individuals we might have funded 5 or 10 years ago. And so they've made it quote unquote, right? They are now chairs of their departments, or they have, now brought in millions of dollars of funding. And so they're at the place that our current slate of grantees want to be. So they give really raw advice on what was so hard. How did you do it? And we let our current grantees ask those tough questions that they may not have the support to ask at their institutions, or may just have not even thought they could ask. So it's an awesome experience. The other thing that we do, which I'm excited about, is on the last night of the V Summit, our grantees have an opportunity to meet some of our current donors. The last night of the V Summit is also the first night of Virginia Vine, which is one of our fundraising events. And our donors who attend Virginia Vine that night will get to meet our grantees. And so what better way to put mission in action, and for our grantees to they'll have on name tags that would say, like, "Hi, my name is Susanna. Ask me about breast cancer." So I think it's going to be just an incredible event for both populations, both for our donors to meet these incredible scientists who are giving everything they have to cancer research, and for our scientists to meet donors who have been impacted by cancer in some really tough ways. So what better motivation for both groups? What better motivation for a scientist to remember why they do what they do, and better motivation for a donor to know that the V Foundation truly is investing their dollars in the best way humanly possible to move the bar in cancer.
Yeah, it's such a great opportunity for both. And I think rare, with many organizations. I love that the V Foundation makes a point to do that. I mean, really pretty consistently throughout the year with different events.
Yeah, we're all in it together. And I think that's the group that I want our donors to meet, because these grantees, they're so excited and they're so just grateful and full of ideas, and they get it, and they work so hard. They are running experiments all night. They are really sacrificing. And I want donors to feel confident that the V Foundation is making good decisions with those dollars, and that our grantees are also making really good decisions with those dollars. Science is expensive, and they have to make hard decisions about what experiments they do and what they can afford. And I want our donors to feel confident that we are a solid investment. If you have $1 or $1 million to invest in cancer research, I want our donors to feel confident that the V Foundation is the place to put their money.
Yeah, for sure. And also, I mean, you talk about how difficult it is to be a researcher. I kind of want to shift our focus a little bit onto women researchers and the challenges that, women in research have. Love for you to tell us about a grant of her own and how you will champion the representation of women in cancer research.
Absolutely. This is a personal struggle, right? It bothers me that women still, in every career, struggle, but we do. So when you're bothered by something, you can either just sit around and be bothered by it, or you could try to make a change. So I've explained to you the V Foundation, our process for awarding grants. And when I came on board as Chief Scientific Officer and began to look at our funding, one of the things that I was not okay with is that the V Foundation had funded significantly more men than women in our history. So that's the bad news. The good news is that when women were nominated by a designated cancer center for our grants, they typically outcompeted men. So I was not as concerned about bias in our review process. What I was concerned about was, if I am dependent as an organization on the nomination process and fewer women are nominated, then what can we do to fix that? The reason the statistic bothers me that there are fewer women being nominated for V Foundation grants than men is that when you look in the professional training, the numbers don't add up. There are more women than men receiving PhDs in biomedical research. There are more women than men pursuing postdoctoral fellowships in biomedical research. And then when you begin to look at the level of assistant and associate and full professor, there become precipitously fewer and fewer and fewer women. So what's happening? So there is an enormous amount of data around what is happening around implicit bias. Women are less likely to be recruited for professorships. Women receive smaller startup packages. Women are less likely to be included by white men as co-authors on papers. Women are less likely to be asked to, we could have a really long conversation, but instead of doing that, what I decided to do was what the V Foundation could do, which was to say, we will have a grant that levels the playing field. We're not taking away anything that we do otherwise, right? We will still have all of our other requests for applications. But on top of that, we are willing as an organization to bust it to raise more money so that we can have a request for applications that you can only be nominated for if you self-identify as a woman. Because here's the thing, Heather, I want to end cancer. That is my job, and that is my personal goal. And I know that we can't end cancer until, when I look at that table of researchers who are doing the work, who are running the labs, it should be 50-50, men and women. So we will do our part as an organization to create opportunities for women who have clawed their way up past all of that bias, gotten a job at a designated cancer center, and they have such a small period of time to now launch their independent careers. We will do our part to make sure that they have time and money to be successful. After that, it's up to them. We are still funding the best of the best. But in this case, you can only be nominated for this grant if you identify as a woman. So I cannot tell you how excited I am. I cannot tell you how hopeful I am that other organizations will follow suit, because that's what it's going to take in order to have the best and brightest minds at the table for victory over cancer.
Yeah, so reading more about a grant of her own, the program, and correct me if I'm wrong, but does it have 2 grants that are awarded?
Absolutely.
Yeah. Can you tell us about each one and their significance?
Sure. So we've talked a little bit about V-Scholar grants, and it's one of our legacy grant programs. And it's truly something I think Jim Valvano would be incredibly proud of. My understanding is that when Jim was being treated for cancer at Duke, he met a lot of young researchers, a lot of young clinicians, and realized from them what a challenge those early career stages are. So I think Jim would be very proud that we have a legacy grant, the V-Scholar, that is intended for that assistant professor. So that's one of our granting mechanisms that is included in a grant of her own. The other is another one of our legacy grants called V-Translational. V-Translational is also incredibly rigorous to obtain, also reviewed by our scientific advisory committee. But in this case, we lift the eligibility restriction on being a young investigator, being an early stage assistant professor. In this case, the eligibility requirement is that the work be translational in nature. And the way that we interpret that is that the project must end in a clinical trial within a couple of years. So the V-Scholar grants can be more foundational in nature. V-Translational are intended to take foundational research, move it towards the clinic in a very robust way.
Great. Well, I've only got, I think, one more question for you. It's kind of a 2-part question. So what has the V Foundation accomplished in its first 30 years, first of all, if you give us a brief history, and then where do you see the V cancer research and cancer overall 30 years from now?
Oh, Heather, how long do you have?
It's very complicated.
Well, to help our listeners who don't think about science all the time and research understand, I can just give some numbers. So we think about lives changed at the V Foundation, and we think about the way that we fund science and how we can change the most lives the fastest. And I think about that of changing researchers' lives and also certainly changing the lives of cancer patients. And all of those who would train in a researcher's lab and all of those who would be impacted by a cancer patient's experience. So in the past 30 years, the V Foundation has funded almost 1,200 grantees. So we're at 1,188 now, I believe. And so that's 1,188 investigators, researchers, whose careers we have launched, whose careers focused on cancer research because of that V Foundation funding. That funding that you get when you start your lab sets the stage for what you do for the rest of your career. Every grad student that trained in those labs, every postdoctoral fellow, they were all exposed to cancer research. In my own lab, because I'm an immunologist, I also had funding in autoimmune disease. And when I got my first grant in cancer, that changed the entire focus of my lab. Everybody in my lab has now gone on to be a cancer researcher themselves, or interested in advocacy or science writing in cancer. Maybe none of them would have been had I not been funded early in my career to be a cancer researcher. So that's one thing we've done, is we have changed the lives of those 1,186 scientists and everyone in their lab. That now they have had 30 years to generate new devices, new technologies, new drugs in cancer that otherwise might not have existed. And so we have also changed the lives of cancer patients. One of the things I'm really proud about at the V Foundation is that we fund across the cancer continuum. We do not have a specific call out for funding in one cancer. Instead, we ask the scientific community to come forward to us with your biggest challenges and your best ideas. And then our scientific advisory committee will rank those. And then we fund where the biggest challenges are. So we fund in all cancers. We also fund across the entire patient journey. We fund all the way from cancer prevention research to early diagnosis, early detection. We fund a lot in treatment because that's a lot of where the big ideas are. We also fund in survivorship and palliative care. So again, across the patient journey. And then Heather, for the past 30 years, we've also funded across the scientific pipeline, which is we fund foundational research. You might have heard it called basic science or developmental science. We fund translational research, which is taking those basic ideas and moving them into animal models. And then we fund clinical research, which moves that translational work into the clinic. I could not be more proud of our funding model, our portfolio. When I am asked, I have never been asked, and I've almost worked at the V Foundation for a year, so I've had not a vast amount of experience, but I do spend a lot of time thinking about our grantees. There has never been a request that I have had to find a grantee who is an expert on XYZ that I haven't been able to find. Our grantees are knocking it out of the park. One of the things that I really love about the V Foundation is our donors drive a lot of what we fund, meaning you can restrict funding in a specific area. And so we have a lot of donors who are excited about making an impact in pediatric cancer. Last year, over 22% of my budget was in pediatric cancer research, which is huge. That's a big number because when you think about federal funding for pediatric cancer research, those numbers are much, much lower in the single digits. And that has happened because we have donors and partners who see the challenges of pediatric cancer. And as I said, the impact not only on the cancer patient, but on everyone around them. So what will the next 30 years look like? Well, one of the changes that we made this year was to increase our grant budget significantly. We talked about earlier that science is expensive. So our V Scholar grant went from $200,000 to $600,000 this year. Our V Translational grant went from $600,000 to $800,000. And we have a brand new grant called a V All-Star grant, which is a reinvestment in our most stellar grantees. It's $1 million grant. Each of those grants pays $200,000 a year for either 3, 4, or 5 years. So in the next 30 years, I predict that we will begin to see significant clinical outcomes from our grantees. I can track right now the number of clinical trials that the V Foundation has contributed to, and I predict those numbers to begin to grow logarithmically because we fund across that research pipeline of basic translational and clinical research, and it takes all of those to fund that pipeline. And because our grants are getting bigger, the ideas can get bigger and the impact can get bigger. And in the next 30 years, I predict that you and I would have a very different conversation, and that hopefully our conversation would be less around trying to understand the nuances of cancer than trying, and more around when you hear that call that you have cancer, it's not something that takes your breath away. It is something that you take a deep breath and you say to your oncologist, okay, well, what's next? And there is a treatment strategy and a design for you, no matter where you fit along that spectrum and no matter where you fit in the disease space. And the V Foundation is going to play a big role of that. And I could not be more proud of our impact.
Thank you so much. You're always so inspirational to listen to. I always feel so much better after talking to you. Thank you for your time. And we'll be seeing you at V Summit, I guess.
I'll see you there, Heather. I hope you bring a pad and pencil, and you will have a really wonderful time meeting our researchers, and they're going to love to meet you. One of the things so I'll give you a tip. So they will go through science communication training on the first day of the summit, and they'll be ready to give you a 90-second pitch for a general audience summary about their research. So ask them to tell you about their research. And if they start using words you don't understand or acronyms, say, now, Susanna told me you would have training, and be prepared not to do that. Because one of the things that I think is hardest for scientists to realize is that one of the ways we most often fail in communication is with each other. We so quickly fall back on using language and acronyms because we think that because Susanna's an immunologist, she clearly understands physics or computer science. And so when we can start from the very beginning and have good, strong communication skills with each other, it enables us to be able to communicate with folks like you who are really interested in what we do and can help us to celebrate it and tell the world.
Yeah, and I hope I'm able to help communicate that to the world too, through video. So excited about it. Well, thank you for your time, and we'll see you soon.
Okay, see you soon, Heather. Thank you.